Hello guys, welcome back. This is Dr. Hadi here. After a long time, we are presenting another interesting video that is from Biochemistry, which is Enzyme Specificity. Before we discuss what is enzyme specificity, the definition of this topic from the book of Satyanarayan is not that much clear, because in the book the definition is started directly, means in the book it is mentioned every enzyme is specific in its action, but exact definition is not there. I would try my best to explain in a very simple way about enzyme specificity. Look, this is an enzyme. Let's suppose this is an enzyme. I would like to write here E, enzyme. And in front of this enzyme we have three objects. These are substrates. I hope you know very well what is substrate. Substrate is anything on which the enzyme acts. So these three objects are substrates, three different types of substrate. Look, this is spherical, and this is triangular, this is some D-shaped. So these are different objects, so means three different substrates are there in front of the enzyme. One special enzyme is there. This enzyme is not going to act on this substrate. Look, this is our substrate. And this enzyme also does not act on this substrate, this one, but this enzyme acts only on this substrate in the middle, the triangular substrate. And what happens, this triangular substrate convert into smaller pieces. Let's suppose this is just for your convenience, just for easiness. We say that this enzyme is specific. Specific means that it is going to act on only one type of substrate. That's why we call it the specificity. Enzyme is not going to act on all the substrate, but it is going to act on only one substrate. This is called specificity. This is just the definition, just to deliver a simple idea about enzyme specificity. Once we go into the detail, into the depth of this topic, you will see more interesting ideas there. But you should know that what is enzyme specificity. This was just a physical definition, a top definition. It is not in depth. Okay, fine. Now the specificity is of three types. The first one is stereospecificity, the second one is reaction specificity, third one is substrate specificity. In this video lecture, we will discuss stereospecificity and reaction specificity. The third one will be discussed in the next video because it requires some more time. If I include this in this video, it will take more longer time. So come to the stereospecificity. Before we go to stereospecificity, I would like to tell you what are stereoisomers. Look, this is just a compound, any organic compound in front of you. You can see here, this is a compound where you can see there are, here we have one carbon here and we have another carbon here. Okay, we have two carbon. H, H, OH, H, OH, H, OH. Similarly, I would like to write another compound with the same two carbon. Fine, same two carbon. And we have one hydrogen, another hydrogen, OH, H, OH, and H. Could you please tell me what is the difference between these two compounds? You see there are two carbon here. We can also see there are two carbon atoms. How many hydrogen atoms are there? 1, 2, 3, 4, 5, 6 hydrogen atoms. We have 6 hydrogen atoms here. 1, 2, 3, 4, 5, 6. Here we have 6 hydrogen atoms. How many oxygen we have? 1, 2 oxygen. Here, how many? 1, 2 oxygen. Both compounds have same molecular formula. Okay, how many carbon are there? 2 carbon, 2 carbon. Fine. So if you see, these two compounds have same molecular formula. This is what? This is our molecular formula, MF, molecular formula. Two compounds. Do you know that these compounds are still differ from one another? These are not exactly identical. Why? Because if you see here on the second carbon, lower second carbon, on its right side you will see there is a hydrogen atom, and here on the right side you will see OH. Looks like the OH on the right side is flipped. In this case, the OH came on the left side, but the H came on the right side. Just you can see the original compound was like this, H and OH. Now the H and OH become like this. So this kind of compounds which have same molecular formula, even same structural formula, but they only differ in the configuration. Look, we use the word configuration. Configuration means the position of atom in space. Here the H is on the right side, but here the OH is on the right side. This is what? This is configuration. So such kind of compounds are called stereoisomers. I have recorded a video lecture on stereochemistry as well, but I cannot revise each and every topic in my video lectures. That's why. So now come to the topic, come to the main idea. If you have an enzyme, look, this is an enzyme. Okay, one thing more. What we call this kind of compound, the D compound, just give the name D compound. If it is a sugar, we call it D sugar. In case of any other compound, we call it D. So a compound like this will be called L and D. L configuration, D configuration. We use the word L and D. So whenever you see this L and D, this means stereoisomers. Okay, fine. Now you have an enzyme. The enzyme which is acting on the D configuration will not act on the L. Even these two compounds are much similar. They are not 100% similar, but they are much similar. But the enzyme which is acting on the D configuration is not acting on the L configuration. We say that enzyme is specific. But inside specificity, what type of specificity this enzyme is showing? So we say this enzyme is showing stereospecificity. You cannot only say enzyme is specific, but you should mention which kind of specificity. So we say this is stereospecificity. Enzyme is acting on the one stereoisomer, but it is not acting on the other stereoisomer. I hope you got the idea. Now we have another example. D-amino acid oxidase. Look, when there is A's at the end of a name, means this is an enzyme. This is an enzyme. This is the name of an enzyme. And this enzyme is acting on what? This enzyme is acting, of course, on amino acid. Yes. So amino acid can also be L amino acid and D amino acid. Yeah. So this enzyme will act on D amino acid. This enzyme, D amino acid oxide, will act on D amino acid, not on L amino acid. So we have amino acid L. So this enzyme will act only on D amino acid. And of course, it is oxidase. This amino acid will be oxidized. Of course, by this enzyme. Now we have another enzyme, L amino acid oxidase. Of course, this enzyme is again going to act on an amino acid. This enzyme is also going to oxidize that amino acid. But the problem is that L-amino acid oxidase cannot act on the D-amino acid, and the D-amino acid oxidase cannot act on the L-amino acid. We say these two enzymes are stereospecific. Now hexokinases, they act on D-glucose. You know, we have different kinds of glucose, D-glucose, L-glucose, and so on. So hexokinases act on the D-glucose. I got this point from the book of Satyanarayan, right? Hexokinases act on the D-glucose, but not L-glucose. No, these 2 points I also got from the same book, from the book of Satyanarayan. A little bit of confusion for the students. Amylases and cellulases. Actually, amylases act on amylase starch. Amylose starch, amylose, you know, starch. I have also my videos on starch and glycogen and so on in Urdu and English language. So amylase act on starch. Which kind of starch? The amylase starch. The amylase starch of 2 types: amylase, amylopectin. You know very well. Inside amylose starch, it's an amylose, not amylase, because if it is amylase, it is the name of enzyme. If it is amylose, it is the name of the substrate. So amylose contain what? Many glucose units linked together. Many glucose units linked together, so on. Many glucose. Come on. Now come to the cellulose. Cellulases act on the what? On the cellulose. Cellulose is a substrate. What is cellulose? A cellulose is also made of what? Many glucose units linked together. Many glucose units linked together. Glucose. So looks like the cellulose and starch are very similar from this point of view. Glucose. Of course, some have many branches, others have less branches. But the main difference is that in starch, the glucose that we are using is alpha glucose, alpha. But in cellulose, the glucose which you're using is the beta. You know, in glucose, in carbohydrate, we have alpha sugar, beta sugar. I hope you might have heard this word, alpha sugar and beta sugar. In alpha sugar, the OH is below, if I was not wrong. In alpha sugar, the OH is below. And in beta sugar, the OH is on the top and at the carbon number 1. So it is the position of the OH, whether the OH is at the top or the OH is below the line. So in this case it will be called as beta sugar, and this will be called alpha sugar. Fine. Now this because of this alpha and this beta sugar, the bond is called alpha bond. The bond is called what? Alpha bond, alpha glycosidic bond, and this bond is called beta glycosidic bond. Now these two enzymes, amylases, act on the amylose to act on the alpha bond, alpha glycosidic bond, and cellulases act on the cellulose to act on the beta glycosidic bond. Here the discussion is about the bond, but where is stereospecificity? Maybe a question arises in the mind of student. Where is stereospecificity? I already told you that this is the stereo isomers alpha and beta sugar. That's why. Now come to the next one, that is called substrate specificity. What is mentioned here about the substrate specificity? This is the definition. Sorry, this is the definition. But come here. What is? I have just mentioned one point here for you people. Isomerases do not exhibit stereospecificity. What is meant by this? So it's a question that can be arise in the mind of student, that are all enzymes show stereospecificity? So my answer will be no. All enzymes do not show stereospecificity. Fine? How? There is one enzyme called isomerases. Isomerases means there are a group of enzymes, not one enzyme group. Isomerases. There is one substrate. Let's suppose A is just one substrate, and there is another compound B. These two are isomer of one another. Let's suppose they have same molecular formula, same structure. Let's suppose, fine, they have same molecular formula and same structure, but I'm going to write one enzyme here. There is one enzyme and enzyme E. Fine. This enzyme is acting on that isomer as well as on that isomer. In this case, E is one enzyme. It is not showing specificity. Why? Because this enzyme is acting on this isomer as well as on this isomer. There are two isomers, but the enzyme is acting on both. Means this enzyme can convert A into B. The same enzyme can convert B into A. It is just like racemase. Racemase is an enzyme. Racemase is an enzyme. It acts on the D amino acid as well as L amino acid. So it can convert D into L and L into A amino acid. There are many other examples of racemases. Racemases are those enzymes which convert one isomer into another isomer. So these enzymes are not showing specificity, stereospecificity. So that was the point that was being cleared. Now come to the substrate specificity, come to the definition. The same substrate can undergo different type of reaction. Let me explain you this. Okay, the same substrate can undergo different type of reaction. Okay, where I have placed my, fine, I think it is missing, but it's okay, we can manage. Okay, let's suppose we have one amino acid. This is the general structure of amino acid, carbon, and here we have carboxylate, COO, and here we have amino group NH2. You can see HN, a variable group R. So this is structure of an amino group, amino acid. Look, this amino acid can undergo different reactions. For example, reaction number 1. If this, if we remove this amino group here, if we remove this amino group, okay, what will left here? Carbon. We will be having H and R and COO. This is just a reaction when the reaction is involving the amino group. This is just an amino acid is going to perform a reaction, but the reaction is targeting which group? Amino group. This kind of reaction of amino acid which is targeting amino group, the reaction will be called what? Transamination. The reaction will be called what? Transamination. Okay, the same amino acid can be targeted this group COO. Means if this COO is removed, then we will be having amino acid like this C NH2 HR. So no CO2 is there. So this kind of reaction is called decarboxylation. We call it decarboxylation. Similarly, and this is an enzyme. If it is in the D form, it can be brought into the L form. So we can call it racemization. In all these three cases, we have what? We have one single substrate. One single substrate. But this one single substrate is going to perform more than one type of reactions. Look, this substrate can undergo transamination. The same substrate can go decarboxylation. The same substrate can go racemization. But who will decide this amino acid to go into the particular reaction? Who will decide? Enzyme will decide. Look, if the enzyme is transaminase, if the enzyme is transaminase, then the amino acid will go on that path, under transamination. If the amino acid, if the enzyme is decarboxylase, what is the name of this? Decarboxylase. Decarboxylase. If this enzyme is acting on the amino acid, then the reaction will be decarboxylation. And now once again we can see specificity. Acting on one but avoiding other. Acting on one but avoiding other. Look, if the reaction specificity was not there, suppose if the reaction specificity was not there, if the enzymes were not reaction specific, then what happened? The same enzyme could bring that amino acid into the transamination, as well as the same amino acid could bring that amino acid into decarboxylation. The same enzyme could perform the racemization. There would be a single enzyme performing the three type of reaction on the same substrate. But no, we have reaction specificity, which mean for one particular reaction there will be particular enzyme, and that enzyme will not be performing another reaction. This is called reaction specificity. An enzyme is following one specific reaction, but the same enzyme is not following another reaction. This is called reaction specificity. I would meet with you at this topic, substrate specificity, in my next video. I hope you got the idea. So see you in the next video. Bye bye.